Hello, this is Jose Luis here at Parametric Camp, and welcome to a new video, a new hands-on video in this series, Advanced Development in Grasshopper. In this practice exercise, hands-on, what I would like to do is I would like to warm up to developing easy implementations of Grasshopper native components in this plugin that we're building together. And so I would like to take all the techniques that we have seen in the previous 3 or 4 videos and put them to practice with a few different forms of Grasshopper components. And what I would like to do is, if you remember in the previous exercises in this series, we have been building together this prototype of a super powerful library, the Parametric Camp library that has all these components with all this crazy, amazing functionality, right? Which we were using to learn C# script development. But what I would like to do is I would like to start porting many of these to the actual plugin in a native way. So we're not going to do all of them right now, but I would like to cherry pick a few that I found interesting, especially from the first batch, so utility, vectors, and nerves. And what we're going to do in this video is that we're going to now start implementing a few of those in a native way. So in this video, we already did in the previous videos add numbers, but we're going to try string concatenation, series, ranges, constructing vectors, and subdividing a curve. All of those components that we already prototyped in a C# way. So in a C# scripting way. So this video is going to be about taking that code and how do we now port that code into our plugin project, which we're going to subdivide in different buckets, and we're going to have different components that do the string concatenation, series, ranges, etc., etc. Okay? We're not going to see a lot of new stuff. It's going to be more about practicing just like simple components. How do you write them? How do you compile them? How do you debug them, etc., etc. Okay, we might see a few new things, such as, for example, how to take different inputs, different types. So how to load a vector, how to load an interval, how to output a list instead of an item, etc., etc. But it's going to be minor things. So if you think you have everything that we've seen in the previous videos under control, you're welcome to fast forward through this video or skip it altogether. We're not going to see much new. It's going to be mostly practice, okay? Otherwise, you may want to check it, of course, because why not? I mean, practice is always a good thing, right? And you're welcome to follow this video with me building it together, or to just like set the speed to 2 times or 3 times or whatever and just watch me like crank all this code through, okay? Beautiful. So without further ado, let's start implementing some of our C# script prototypes. Let's start implementing some of our C# script prototypes from the previous videos into our native plugin. Okay, let's get hands-on. All right, so let's get started. If you remember, what we did in previous exercises was we had this large file that we were using to prototype all these custom components that we wanted to do by prototyping them by using C# script components. So what I would like to do over the course of these videos is to take some of those examples and port them to native implementations so that we can see how that process works. And if you remember, we did for native, we've already done addition, which was basically just taking 2 numbers and adding them together. So I'm going to do a few. I'm not going to do all of them publicly in the series. I'm just going to do a few that I think are interesting to introduce new concepts. And the next one that we're going to do is going to be string. It's going to be a string concatenation, because I would like to show you how to take different types of inputs and different types of outputs. And perhaps we can also do length as an output of that component. Anyway, so what I'm going to do now is I'm going to close. Oh, no, I'm actually not going to close. What I'm going to do is the algorithm is pretty straightforward. I don't think we need to copy this. Anyway, so what I'm going to do is I'm going to close Grasshopper. I'm going to go back to my plugin. And one thing that I would like to do before we move on is that, first of all, at this point, the Grasshopper plugin component, the one that came as a template with the plugin, is not going to be useful anymore for us. So what I'm going to do is I'm going to just delete this file from the project, okay? Because we already know everything we need. We don't need any more sample files. And the other thing that I would like to do is that because we're going to very soon start having many different components in many different categories, as we have done with the prototypes. We had utilities, we had vectors, we had NURBs. So I would like to also start having buckets of code inside of my project of sorts. And the way to do that is by using folders. So for example, if you remember, in Grasshopper, addition, strings, etc., all of those, we were calling them utility components. So I'm going to then create here in the project, I'm going to create a new folder that I'm going to call utility components, for example. And then I'm actually going to drag and drop the add numbers one inside. Okay. And then now I have these folders that I can use to set different groups of components, if you will. That will have nothing to do with how they will show up in Grasshopper. If you remember, they show up grouped depending on which names I give this. I give the components in the constructor. And actually, instead of operators, I'm just going to change this. Oh, maybe it's called operators. I don't know. Now, let's just be consistent. Utilities. Let's be consistent with what we did for the prototype. Okay. So utilities is going to be that. All right. So I think we're ready to now do string concatenation. So similar to what we've done before, I'm going to right click on the folder. I'm going to create a new item, and that item is going to be an empty Grasshopper component that I'm going to call, for example, a string concatenation component. All right. Beautiful. So if you remember, I'm going to dock this here on the side so that I can have both things side by side. And so, for example, string concat, I think this is not a great name. So I'm not going to dock them side by side because it's very difficult. So string concatenation, that's going to be the large name. String concat, that's going to be the short name. This concatenate two strings, and then the category is going to be pcamp, and the subcategory is going to be utilities. All right, beautiful. The next thing is registering the inputs. Remember, we used the pmanager object, and then here we used the function to add whatever data type as an input. So for example, because we're going to concatenate strings, I think we will need to do add text. Text is how Grasshopper refers to strings. The string name is going to be string A, nickname is going to be A, description is going to be first string to concatenate, and then the parameter access is going to be item. So we're going to take one unit at a time. And then I'm just going to copy and paste this and change it to B, and then second string to concatenate, etc. And then for the outputs, we only want one output. Actually, maybe we want two outputs. I don't know. Let's do two outputs. So we're going to have add text, which is going to be the concat is going to be the name, C is going to be the nickname, concatenated string, and the access is also going to be item. We're going to drop out a single item. And then in this component, I'm going to also output, as a byproduct of the calculation, I'm going to output the length of the concatenated string. So I'm going to say pmanager dot, and in this case, I'm going to add a number, or I could actually do an integer, because I know that that number is not going to have a decimal part. And I'm going to call this length, and then this is going to be called L, length of the concatenated string. All right, and then the access is going to be item. Beautiful. Okay, great. So now we have the two inputs. Now in the solve instance, what we need to do is we need to add first. We need to retrieve the two input items from the inputs. Remember that the way we did this was we defined two variables. So for example, string A, string B that we initialized to 0, and then we use the data access argument also as a form of manager to get data in and out of the component. So what we do here is we say da.getData, and then the data that we want to take is, first of all, the index is going to be 0, so the first item, and the destination where we want to store that data is going to be on the variable a that we just declared. All right, and remember that typically Grasshopper uses this pattern where we just say, if we didn't get that data, if that didn't happen, then just return. Do not keep executing this solver, because if we don't have data, then we can't really do anything. I'm going to copy and paste this, and now I'm going to change this to the second input, so number 1, and the other variable that I want to store. So that in predefine empty storage variables, if you will, and then fetched input data, so that's going to be the second one, then solve, so the algorithm, that thing that we wanted to do, which in this case is going to be, I'm going to define concat as a plus b, which is very straightforward, and then the outputs. What are the outputs going to be? Well, first of all, or actually here I'm also, just to be really, really verbose, I'm going to define length as concat.length of the string. Okay, so that I just have all the data that I'm going to need to output. And then the output is just going to be as simple as saying da set data, and in the first output, I want to output the concatenated string. So that's one thing. And then da.setData, in the second one, I want to output the length of the string. All right. And for these exercises, I'm not going to bother with icons, and the GUID has already been generated automatically. So this is as much as I need for my component right now, I think. So let me run this and see if it works. And if we get that nice, I'm going to open Grasshopper. Okay, and then it's opening up in my other screen, PC, utilities, string concatenation, and then you can see that let's give it a try. So I have Jose and I have Luis up, and I put them together, and I get the results that I get are, first of all, Jose Luis without the white space because I forgot to add it, and then number 9. So maybe I want to add Jose and a white space up there, and then 9 characters for that. Okay, beautiful. So it's working. That was pretty easy. String concatenations in utilities. What are we going to do next? The next components that I would like to do are going to be the series component and the range component. And I think these are going to be interesting because it's always great to refresh, like using a for loop to design a sequence of numbers, etc., etc. But on top of that, we're going to see how outputting a list of numbers is going to be slightly different. We just need to work a little bit with the parameter, as well as taking as an input a data type that is so Grasshopper specific, such as intervals. Okay, so I'm going to basically take this algorithm and I'm just going to copy it. All right, because I would like to now start showing you how to transition from C# script written kind of code to more like native oriented written kind of code. So all right, so we're going back to string concat. I'm going to add then a new item. The new item is going to be an empty Grasshopper file that I'm going to call series component. Okay, and same thing. So we're going to start with, it's going to be called, the name is going to be series, the nickname is going to be series, create a numerical series, and then category is going to be pcamp. Remember that name needs to be the same for all of our components, otherwise they're going to land in different places. And then the tab is going to be, the category is going to be called utilities. This component, if you remember, it takes S as the, the starting value, N as the number of values or the difference between them, and then C is the amount of, which is very confusing. I never, and S and C. Okay, so let's define those parameters then. So pmanager dot add, and then we're going to add a number because the starting value can be whatever. So start, and then s, first value in the series, okay? And this is going to be of the type item. The next one, p manager, like add number as well, is going to be the gap, the step, okay? We're going to call that n, step size between numbers in the series. And then this is also going to be an item, all right? And then last but not least, I'm going to add here an integer, integer. I never, I keep mispronouncing that. I'm going to add an integer because the amount of numbers in the series needs to be a number with no decimal part. So number of elements in the series, okay? And is going to be also an item. So we have that. And before I lose it, I'm just going to go here to solve instance and copy paste what I just had from before, which is not going to work, but we're going to rewrite to adapt it to native development. Okay? Beautiful. Now for the output, it's going to be the same. We're going to take p manager and we're going to add a number output, and it's going to be called s. Parameter is going to be the series, going to be s, and then it's going to be the numerical series. The only thing that is going to change here is that the parameter access, because we're going to be outputting a list of numbers, is not going to be an item anymore. It's going to be from the list, it's going to be a list. All right? Beautiful. Okay, I think we are quite ready for this. So now if you remember from string concatenation, we said, first of all, we predefine empty variables to store inputs. So that's going to be double is going to be start, and which we initialize to 0. Double is going to be step, which we also initialize to 0, and integer count, which we also initialize to 0. Beautiful. The next thing we do is we fetch the inputs, and we use this if the DA element cannot get data on input 0 and store it in start. If that doesn't happen, then stop executing. All right. And I'm going to copy this 3 times, and that's going to be 1 and 2, and this is going to go to step, and this is going to go to count. Beautiful. All right. And now the algorithm, okay? For the algorithm, we can pretty much copy and paste the code that we had. So I'm not going to go over how the series are done. The only thing that we need to do is just to change the names of what things are. So I created a list for the values that I initialize to be empty, and then I iterate between 0 and the amount of elements that I want to add. And then I calculate a value which is always going to be the start plus I times the step size. And then we add that to the array of values. As simple as that. And then for the outputs, the only thing that I need to do is I need to take that list now and output it through the first output. The only difference here is that before we were using this method called setData, which just sets one single unit of information out through the component. In this case, because we want to output a full list, the difference will be that we're going to do set, and you see how we have set data list, and set data tree. So I'm going to set the data list, and that's going to be 0 for the index, so the first output, and then vals is going to be the list that contains all these numbers. So I'm going to save that, and I'm going to stop Rhino, and I'm going to load. I'm going to fire a new Rhino that is started from, and I'm going to fire Grasshopper from my Visual Studio. And I'm going to dock it here, and I'm going to go here, and I have series. Okay, is this going to work? I have series, and then I have, you see how nicely the descriptions that I wrote in my component are coming up. That is very nice. So let me start with for example, we start with 0. The step size is going to be whatever it is, you know, blah, blah, blah. And then we're also going to do 10 units, for example. And then we get an output, which is going to be this numerical series that starts at 251, 2 units, and 10 elements. All right? What's beautiful about this is that the output is a list. It's not a single item anymore. Okay, let's try the same thing also with the range component. I'm back in my oh boy. I am back in my Visual Studio project, and I'm going to go here then to the utility components, and I'm going to add a new item, and I'm also going to do an empty Grasshopper component. This is going to be called range component, and we're going to do the same thing. We're going to add the description, so that's going to be range creates a numerical range, and then the category is going to be pcamp, and the subcategory is going to be utilities. Okay, beautiful. For the range component has two inputs. One is an interval, that's the first one, and the second one is a number with is an integer. It's an integer, right? Because it's the amount of steps or amount of divisions. Okay, so I'm going to say pmanager dot, and then I'm going to look for add interval. You see, there's a one-dimensional interval here. So the string name is going to be domain, and then D is going to be numerical domain for the range, for example, and it's going to be of the type item. Okay, the next one is going to be pmanager.add, and then it was, I think I said it was an integer, right? So I'm going to say integer parameter steps, and that's going to be s, for example, number of steps to divide the range in, for example, and the parameter access is going to be item. Beautiful. And then last but not least, the output is going to be pmanager.add number parameter, because they can have decimal part, and I'm going to call this range, and I'm going to be r, and it's going to be the numerical range, and then the output in this case is not going to be an item, it's going to be a list, because it's going to be a bunch of different numbers. All right. Okay, then for the instance, we go again. This is a little tedious because there's a lot of stuff that needs to be done, but yes, so empty collection variables. So that's going to be an interval. Okay, so that's going to be the domain, for example, which I'm going to initialize to a new interval. Actually, I don't think I need to initialize this one. I forget. Let me just try. And then an integer, which is going to be steps, which I'm going to initialize to 0. Then I'm going to fetch data, fetch inputs. What is this telling me? That I'm not using it, right? Yes, I'm going to fetch the inputs, and I'm going to say if we don't get data from input 0 and that goes into the domain, then return. And I'm getting here I'm using an unassigned variable DOM, so that means that I do have to initialize this to a new interval of some kind, right? So an empty interval, for example. And then here, I'm going to do the same for input number 1. I'm going to send this to the steps input. All right, beautiful. So now I'm going to drop here the algorithm. And I had copied it from... I forgot to paste it. Okay, so let me go ahead and copy the algorithm from the component. And I just copied the code from the prototype that we did in C# scripting, which I'm going to paste here. And as you can see, I need to just basically rename a few things. So first of all, we're calculating the step, which is going to be the end of the domain minus the beginning of the domain divided by the amount of steps that I want for this. And then here, I'm going to have steps plus 1, and then this is going to be the start of the interval, domain 0, steps, and adding those values. All right? And then, as we did before, for the outputs, the only difference is that instead of using set data, I'm going to use set data list. So set data list over output 0 using values, the list that I just created. Okay? Let's give it a try, see if it works. I'm going to load this, and I'm going to load Grasshopper. And I am going to load this, and you can see that I already have range here, and range is asking me for a domain, for example. I'm going to construct a domain that is going to go from 0 to 1, probably. Yes, 0 to 1, and I'm going to subdivide it in 10 steps. So that would give me a numerical range with 10 subdivisions or 11 elements. Okay? Beautiful. This is working. All right. So what is next? I think next is going to be vectors. I mean, we have to do vectors, of course. How can we not do vectors? Oh, no, I have an idea. Something that I would like to do. Yeah, let me show you what I would like to do. Something that I would like to do before moving forward is that if you remember when we were prototyping our utility components, we kind of loosely grouped them in kind of arithmetic, string manipulation, numerical sequences. We had like this kind of 3 large buckets that we used to store them. But if you see my current layout, you can see that the components are kind of all there, which it's okay, but it could be better because if you remember, Grasshopper typically has a way to have these kind of separators and to allow you to group different components thematically or by proximity of functionality, or however you wanna say that. So I think it would be nice to somehow separate these 4 components into 3 groups. This one in arithmetic, these 2 at the very end as numerical sequences, and this one for string, especially because whenever we have the whole thing done and finished, it will be nice to have them like stratified by functionality. So that is actually something that we can do also with Grasshopper components if we do them natively. So let me show you how to do that. I'm going to close all of this, and then what I'm going to do is I'm going to go to add numbers, right? And when we create a component from the template, it gives us all these overrides, like the register input, register output, solve instance, and you basically just have to fill in the code. The one override that doesn't come out of the box is the exposure override. We've seen this in previous videos, but the exposure override allows you to have a component show up or not show up on the tab, but it also allows you to customize which bucket the component shows up within the expandable category. So instead of saying whether the component is hidden or not, you can choose if the component is primary, secondary, tertiary, quaternary, etc., which means whether if the component is in the first bucket, in the second bucket, in the third bucket, etc. So for the add numbers, I'm going to choose primary because I want all the operators in one large bucket. I'm going to copy this. I'm going to go to string concatenation, and I'm going to add this somewhere out after the solver. And instead of primary here, I'm going to choose secondary. So that's going to be the second bucket. And for series and for range, I'm going to add a ternary. So these are tertiary. They're both going to go into the tertiary group. All right. And as I do that and I save all this stuff, I'm going to start Rhino again. And hopefully the components within the tab now are going to be nicely ordered in 3 groups. Let's hope, let's cross fingers. Did this happen? Parametric camp. Hooray! Beautiful. So you see how now we have add numbers, separator, string concatenation, separator, and the 2 here. Okay? Which is great because as soon as we start adding more, it's going to be nice to see them with such separations. Okay, so then without further ado, let's go and do some vectors. And I think the ones that I would like to do is going to be vector. We're going to construct a simple vector. That one is not going to be inside of utilities. It's going to be inside of another category, which is going to be vector components, for example. So I'm going to right click on my project. I'm going to add a new folder, and I'm going to call this vector comps for vector components. And here I'm going to right click on the folder, and I'm going to add a new item, which is going to be an empty Grasshopper component that I'm going to call vector. I'm going to call construct vector component. And this component is just going to take x, y, z values and output a vector. We already know how to do this. I just don't feel complete if I don't do vectors. You know me already from previous videos, right? So we just have to have vectors. So construct vector, and then the nickname, what, vector, new vector? I don't even know what a nickname could be. Create a vector from components, for example. And then the category is going to be pcamp, but the subcategory is going to be a new tab, that is not a tab, a new expandable, whatever that's called, that is going to call vectors. All right. Now the inputs are going to be 3 numbers, so pmanager.add number, and then x, and then the nickname is also going to be x, and then it's going to be x component, super fancy, right? And then the access is going to be an item, and then I'm going to copy and paste these 3 times, y and z, y, y, and z, and z. We have 3 components, and then the output in this case is that I'm going to add a vector parameter, which I'm going to call vector v and vector. I don't really know. Parameter is going to be an item. All right. And then the solver is going to be extremely straightforward. I'm going to skip all the annotations for this one. I'm just going to say double x equals 0, y equals 0, and z equals 0. And then I'm going to fetch the component. So I'm going to say if da.getData for 0 and ref x. If it didn't work, then just return. And I'm going to copy this 3 times. And I'm going to do 1 and 2. And this is going to be y. And this is going to be z. And then vector, I'm going to create the vector. So vector 3D v is going to be a new vector 3D from x, y, and z coordinates, which I'm going to output through the DA set data on output 0 and use v for the output. Okay, really straightforward. Let's see if this works. What we should be able to see is a new category that is going to show up on our plugin. Okay, having this one component. All right, vector, construct vector, and it looks like it's working. So I'm going to plug stuff here. Oopsies, I'm going to plug stuff here and here and here. I'm just being super lazy right now by using the same output. But yes, you can see that we have a vector that it's working. Okay, but I'm not going to do any more vector components because they're really straightforward, and I don't want to waste time going over things that we already know. Perhaps the last one that I would like to do is divide curve, and let me show you why. If you remember from the nerves components, we had a lot of nerves operations, but there was this one that was divide curve, and we divide the curve into a bunch of different numbers. What was interesting is that we used a couple different methods to do this, which are very similar to each other actually, but I would like to also reproduce this one because taking geometry as an input requires also customizing the type of the input, etc., etc. And because in a way, this is the first component that is going to be using a bit more of a complicated algorithm that requires a Rhino common, etc., which is going to be basically copy pasting again. But for the sake of completeness, perhaps a more complicated or more advanced geometry manipulation algorithm could be interesting as an example. This is going to be, I believe, the last one we're going to do for this first round of practice exercises. Okay, so so let's go back. I'm going to close everything here. I don't want to go, etc. And then what I'm going to do is I'm going to create a new folder to store these components, which is going to be right-clicking on the project and adding a new folder. And I'm going to call this nerves comps. All right. And then here, I'm going to say add a new item, and then it's going to be divide curve component. And before I lose the copy pasting that I've done, I'm going to go here to solve instance. I'm going to paste the code and I'm going to comment it out so that I can see it and reuse it as soon as I get to this part. Okay? So divide curve. I'm going to and this is going to be div curve, for example. Description is divide curve in segments, for example, in points, I think it was. And then category is going to be pcamp, and subcategory is going to be nerves. Beautiful. What is the input? Where are the inputs going to be? The inputs are going to be pmanager dot, and I'm going to add a curve components. That's a parameter. So the name is going to be curve. This is going to be C curve to subdivide. That's going to be of the type item. Up. So wait. So this parameter dot item. That's going to be one thing. The other thing, the other input was an integer, because that's the amount of steps that I'm going to subdivide the curve in. So pmanager, oh boy, I'm getting tired. All right, so steps, and that's going to be n, for example, steps to subdivide the curve in, and then that's also going to be of the type item. All right. And I forget what outputs did we have. So we had the points and we had the tangents, right? And the parameters. I think we also outputted the parameters, correct? Yes. So the three outputs are going to be lists. So what I need to do is I need to say pmanager add, first of all, I'm going to add a point parameter, and that's going to be points, and then it's going to be p, and that's going to be subdivision points. I'm adding typos, and remember that this one, I'm going to set the type, the access of the output to a list, so because we're going to have multiple elements. pmanager, the second one I'm going to output is going to be the parameters at which those subdivisions happen. So I'm going to say add numbers, and then parameters, and that's going to be t, and then parameter curve parameter at the subdivision, and it's going to be of the type list. And the last thing I'm going to do is pmanager.add vector parameter, because those are going to be the normals, the tangents, sorry. And then I'm going to say uppercase T, and there's going to be tangent curve tangents at the points, for example. And then I'm going to say that this is going to be of the type list. Beautiful. So how are we going to do this? How are we going to do this? Oh, we're going to define inputs. So first of all, I'm going to define a curve that is going to be the one that I'm going to initialize, and then an integer, which is going to be steps, which I initialize to 0. I don't think I need to initialize the curve, because it initializes to null by default. And then if I don't get data in parameter 0 that I pass on to curve, then stop executing this solver. All right. Well, it looks like I do need to assign something here, so I'm going to assign null here. All right. That's one thing. If I don't get data at input 1, then go to steps and then return. All right, beautiful. So with that, I should probably be okay. And then I'm going to say here, I'm going to define the algorithm, which is going to be find the parameters of the subdivision. So here I'm going to replace curve, and n is going to be the number of steps, okay? And you know what? Why we going to do it the other way around? So at this one, I'm going to call it C, uppercase C, which is what I had already, uppercase Z. And then steps is going to be uppercase N. And therefore, I have the same notation that I had in my script. So I literally copy pasting is going to work exactly well. And then the outputs are going to be, what are the outputs going to be? So for the points, so I'm going to say da.set data list on the first output, and that's going to be points. And the fact that this is an array as opposed to a list doesn't really matter, because C# knows how to take elements and march them together, take elements that are similar, like lists and arrays, and convert between the two, basically, because they're both enumerable, etc., etc. So set data list for number 1, we said that's going to be the parameters. So I'm going to pass here parameters, and da.set data list, and the output 2, those are going to be the tangents. All right. Okay, let's see if this works. Okay, where is Grasshopper? Grasshopper, Grasshopper, Grasshopper. Okay, and then we have vectors, we have nerves, divide curve. Let me pick up a curve from Rhino. So I'm going to do this, for example. I'm going to pick up a curve that I'm going to load here, and then I'm going to pass here, and I'm going to say 10 subdivisions, for example, and you can see that I get the points, and then I'm going to get the tangents, the parameters, and I'm going to get the tangents. Okay, so it looks like this is working. All right, so I'm going to take a second to take all that we've done today in this video and shape it into a file that has all these custom components that we just made. Give me 1 second. And here we go. I have taken all the components that we just created today: additions, concatenation, series, range, construct vector, and divide curve, and I just put them together in a file showing all the work on native components that we have done in this video. I am very happy if you've made it all the way through. Now we have like a bit more of like fluidity, and our fingers are ready to start like cranking really interesting components with more features, etc. I just wanted to warm up a little bit with the basics. So we're going to now, in the next videos, we're going to see other techniques that we have learned for C# script components and how those would apply to native components, such as, for example, error handling, or data structures like trees, for example. They're handled a little different, or custom pre-visualizations. They're all similar in different ways, but there's like a few things to keep in mind when we do them natively. So thank you for making it all the way to here. I appreciate if you thought any of this was useful. Maybe consider liking this video or subscribing to the channel and all those things. And regardless of that, I will hopefully see you in the next videos in this series. Thanks a lot. Bye bye.